Zip, zap, zoobity bop. Oh, wait, I can't move. There we go. Alright, so, just had some noodles and I'm all ready to continue on. So we got our dude, he can run, he can jump up and down. That gravity's a little fast. I still don't like it. It doesn't feel right. I'll talk about a little bit about this a little later in this video, but yeah, we can tune the values in here to kind of, you know, get the feel of a jump that we want. But I'm going to significantly decrease the gravity. I'll leave the escape velocity the same. Not escape velocity, but the initial velocity here. It's going to jump higher now. It's a little better. A little strange. I don't know if I like that trajectory much. But, well, whatever. So, the problem we're going to deal with now is the fact that if you hold the button down, you jump, you're just stuck there after. You just plant your feet down the ground, and you're gold bricking. That's what they call it, gold bricking. I'm pretty sure that's not what they call it. But that's what I'm going to call it. So what the problem is here is that the jump state will always, like upon collision, the jump state is going to send you into the standing state. And the standing state will not transition to the running until you actually push the button. If you're holding the button, that's not good enough. You got to push the button. You got to punch the keys. So, what would be our solution to this problem? Well, one solution I could think of is, on collision here, when you're transitioning here, you put an if statement, and you check to see if the direction keys are being pressed. And if they are being pressed, then you would clearly transition to running. And if they're not pressed, you would transition to standing. And that's one way of handling it. The problem is that's not the way we have architected our system here. Here's a little diagram I drew while eating my noodles. And as you can see, we've got our sprite control object here, and it acts as a kind of like adapter. It hooks up our keyboard client to our basically our state machine via the sprite object in the getState call. Now in this situation, Sprite has no way to access the keyboard client or even the sprite controller. It doesn't know about it. It just sits around passively waiting for events, and when events come to it, it handles them. That is the way a state machine, a pure state machine, generally works. So one thing we could do, I suppose, is we could add a we could add a pointer to the controller, and that would allow us to access that. We could add like functions to the controller, interfaces like I don't know, like check key or whatever, and that would obviously go to keyboard client, and it would use the like is key pressed thing, right? So in the keyboard client and server system, we have two main systems of accessing keys. Where's my keyboard client? We've got the general basically get or read functions, read character presses and read key presses. And then we have is key pressed, which will check the state, the current state of the keyboard, which keys are currently being held down right now. So we could use the key is pressed. We could expose that through our sprite control, and we could give our sprite access to the sprite control. We'd have to put that in the core. And then, sure enough, player jump could check the current state of what keys are being pressed to determine what sprite state to transition to next. However, I don't want to do it that way. I don't want to, at this moment, I don't really want to add all that extra entanglement of objects to each other, cross-coupling. Sprite control is already coupled to sprite, and then we have to couple sprite to sprite control, like circular pointer and stuff like that. I'm like making up terms, by the way. I don't even know if that's a real word. But you get what I'm saying. They're pointing to each other, and it's kind of messy. I don't want that. I like the way I like our system right the way it is. I think we got a good thing going. So, how am I going to solve this problem? How is Chili going to extract himself from this conundrum? Well, what we're going to do is, first I'm going to clear my nose. Much better. Okay. Next. Let's see what we got here. Those spicy noodles that give me the nose runs. In the player jumping thingamajigger here. Oh, my leg's so itchy. I'm gonna add a bool. Bool is... Now, what is the name? I want to call it is moving. But that's dumb, because if you're jumping, you're always moving. But what I want it to mean is, are we moving horizontally? Are we pressing the horizontal keys? But I don't want to name it in something referring to keys, because we're not at that level anymore. So I'm going to say is moving. It's dumb, but I like it. I like dumb things sometimes. Okay, so we got is moving here. Now, in our constructor, we're going to go bool is moving. And we're going to add that in here. And so basically, if we call this from a player standing, we're going to call it with false. But if we're calling it from player running, we're going to call it with true. And that will initialize our is moving in here. Then we handle on control direction press. What was it again? I forget. Let's go to player. Let's go to sprite state. Yeah, that looks good. Go back. Should have done that from the beginning, but you know how it is. So we're going to handle our left and right presses, our direction presses. So let's do that. Let's go let's go player jumping on update. Here we go. Copy that. And we're going to go on control direction press by direction D. How's that? Good. Okay. Now, if a direction is being pressed, for now, for our behavior for right now, we're going to say if D is equal to core.dir, meaning if the direction that was pressed is equal to the direction that we are currently pointing. That's not right. We need a double equals here. That could have been disastrous. There we go. if D is equal to dir, the same as, then we will set is moving equal to true. Not truer, true. That seems all right. You know what? Fuck that. Fuck that in the ass. We're going to allow our character to change the direction they're pointing in midair. Because that's something you could do, right? It would look stupid, but you could do it if you wanted to. Probably. So we're just going to go dir is equal to D. How's that? Why? Oh, core.dir. Pardon my French. How's that? That's good. So we're setting our direction to whatever direction was pressed, and make sure that is moving is set to true in case it was false. Moving on, we go to on control TRL LEASE, and you don't like me for some reason. D, bam, bam. How's that? How you like me now? All right, then if the release direction, core.direction, is equal to the direction that was released, set is moving to false. Now comes the place where we actually use the is moving thing. We're going to, in our transition code, if is moving, transition new player running. Oh, you don't know about that, do you? We'll fix that. Include player running. Alright. Now how's that? That's good. Add a core in there. Else transition to standing. There we go. We instead of basically what this is doing is instead of polling directly the state of the keyboard, we are remembering via this variable whether a direction key is currently being pressed, which is something that I tend to like to avoid. I tend to avoid having the same state being represented independently in two different places, such that you have to maintain them both. But in this case, the ends justify the means, because I want to maintain my current architecture of a strict or a kind of pure event-driven state machine. Alright, transition new player jumping, no overloaded function. Right. So now on, this is player standing, so we want is moving false. And player jumping, player running, and in this case we want it true. We might even be able to skip this, this, what do you call it? This parameter here by examining SX. If SX is equal to 0, obviously we're not moving, otherwise we're moving, but whatever. I'm just going to leave it the way it is for now. I might refactor that later. It's not a big deal. This is just a more explicit way of doing that. So we run, we jump, and we're running again. Problem solved. I feel like our motion is still a little slow. Player running. Let's boost that up to 5. 6. 5. 6. We'll double our speed, man. How's that look? Bam! Oh, now we're blazing. Boom! Look at us jump. Whew. I just had like a fucking... I had this sinking feeling that I wasn't recording for the last 15 minutes, but no, it's all good. It's all good. Alright, I like this. I like the way this looks. However, this isn't really the way... Oh! That was interesting. That is interesting. That was kind of unexpected, but then again, that makes a lot of sense. So if I'm in mid-jump, if I change direction, like watch this. Bam! Whoa! Look at me! Look at me, Mom! Look what I can do! Woo! Woo! Yeah. A little unexpected consequence of my changing player jumping here. Where is it? Player jumping on direction. Press. So by changing the direction variable here, or allowing it to change, I can change my speed in midair, because the speed is of course, or my motion, the direction of motion, because the direction of motion, the velocity vector, is transformed by the direction object. So change your direction, your velocity vector automatically reverses, and you're moving the opposite direction. Right. And that's fine for now, I want to say. Yeah, that's okay. Now, I want to get a little bit... this unexpected thing kind of threw me for a loop, because what I wanted to do... What I really wanted to do here was show you what, you know, in a sense, what realistic jumping mechanics would look like. You know, physically plausible mechanics. You jump and you're in air, and once you jump, you've committed to that jump. You can't change it now. Won't stop, can't stop. So you can't, like in midair, you can't say, oh, I don't want to go that far. And since your speed, your running speed, there's only one speed, right, you're running at, your jump is always going to be the same vertical or horizontal distance. You can't, like, adjust how far you're going to jump. I just want to jump a little bit. No. You're always jumping the same amount. And I mean, if you had like a controller with pressure sensitive buttons, you could tweak the values of your initial velocity depending on how hard the button was pressed. And obviously if you had an analog running or an analog stick, you could control your running speed too. But for your normal digital controller, which is what most of us had up until like at least the PlayStation 1 era, that's not how you could control it. So, but if you look at a game like Mario, you had pretty good control over your jump, your arc, and your distance, and so forth. So, I guess the next thing for us is to tweak our jumping mechanics so that we can control them a little better with the keyboard. So how are we gonna go about that? Well, first of all, what? That's the question. Controlling our horizontal movement with the direction keys, I guess, would be my first goal. Now, how we're going to accomplish that is go to player jumping. We're going to add new variables now. So we got Vy. We're going to do float Vx. Just trying to think of how I want to do this. Now note that that's not Sx, but that's Vx. So this is going to be a value that we do not transform. It's going to hold its direction as part of its value. Now, so we have Vy, Vx. Acceleration of x. Sax. Speed acceleration. So this is going to be a scalar acceleration. It's not going to be vector. It's not going to have direction. It's going to be dependent on the direction we are pointing. Yeah? I like that. So we'll get rid of Sx. It's not important anymore. Acceleration y is fine. One more thing we're gonna have. Constant float I want to add one more. Float SDX. Speed decay. What's the word I'm looking for? Can't think of the word now. Speed decay. So when we're not pressing any direction buttons, this is going to be the rate at which our speed decays to 0. Whereas acceleration rate is when we press a direction button, how fast do we accelerate into that direction? Speed decay, not constant, coefficient. I'm not even sure if coefficient applies in this case, but I want to use it anyways, because it's a fun word. Okay, now, constant float, max Sx. This is our maximum speed. In either direction in the x, because if we're able to accelerate, we don't want to be able to accelerate indefinitely and just kind of like zoom to the right. I mean, maybe there's a platformer where that would be a fun mechanic, but in general you want to accelerate only to a certain degree. In fact, although we can't fall very far in a certain situation, if you have a platformer where you can fall far distances, you probably want to limit your Vy as well. You don't want to be able to accelerate indefinitely, or like if you fall for like 3 or 4 seconds, you're going to be zooming down, be like burning up in re-entry speeds. So, but for now, we won't worry about that. We will worry about our maximum speed in the x direction. So we got our maximum speed x, we got our decay coefficient, we have our speed acceleration. I think these are all the variables we're going to need for our jumping. Now, Sx is no longer a thing. So we need Vx. There's a couple of ways we could handle this, but I'm going to make it so that the caller has to pass us the velocity now. So they have to transform it at their end and give us the velocity, our starting velocity. So we're going to have to change our callers, well, just player running really. What else? What else do we want? Okay, we need speed acceleration X. We need that smooth sax. And we're going to set that to 0.2 to start with. We'll tweak these values as we get a feel for what the mechanics are like. Speed decay coefficient, speed decay X, will be 0.075. I'm just pulling these numbers out of my ass, people. I have no idea. And maximum speed in the X direction, max SX, will be, let's see, our maximum speed running is 6. So jumping, I'll make it a little faster just for funsies. We'll say 7.5. Because jumping always kind of feels faster, even though it might not be so in truth. It has that feel to it. The feel of a jump. Alright, so we've got our all our parameters here. Const. This is a const. Speed acceleration is a const. These are all constants. The only things that are actually changing are velocities and our is moving bool. So we've got the framework set up here. And we're not adding any new functions. We're just going to handle the ones we've already got. So let's go over. Oh, before I forget, I'm going to go to player running. And I'm going to go down here. Where is it? SX. So we're going to change that. We're going to go core. No, I said core. Dot direction dot transform SX. So we're going to transform XX before we pass it on to the jumping, because we need to get it into a vector format from a speed format. Just do that because I'll probably forget it and it'll mess me up later. Alright, so player jumping. Where are we? Player jumping, I said. Okay. Let's go here. Okay. Why am I on player running? Let's fuck it. I'm going to go here. We'll do it live! Alright. So since we've got VX now, we're not going to transform it anymore. Transformers need not apply. Okay, so VX, VY, this stays the same. I'll make a little thing here. So VX, here's where things get a little nasty. If is moving, Vx plus and equal, no, Vx is equal to minimum, now, Vx plus and equal core.direction.transform speed acceleration x. So we transform our acceleration if we are pressing a motion key. Then we go Vx is equal to I can't use maximum and minimum easily because it can be plus or minus. Because of this dir transform thing, Vx could be plus or minus. I want to use max and min. I want to use them so hard because they look. I like the way they look when you use them. I like the way they feel on. Oh, never mind. Forget about that. How am I going to do it? Vx plus the transformed one. I can't do it. I can't find a good way of doing it. So if Vx, maybe I'll think of it later, but fuck it, we gotta move on. If Vx is greater than max speed x, Vx is equal to max Sx, else if Vx is less than negative max Sx, Vx is equal to negative max Sx. That's how we're going to handle that. Yeah, I guess I could have used max and min for this one, right? All I've got to do, let me just think this out now. Vx is equal to the maximum of Vx and negative max Sx. And Vx is equal to the minimum of Vx and max Sx. How's that? That works. Although I believe this one would be slightly more efficient for reasons. But I'm going to use this one anyways because it looks nicer. I don't care too much about speed difference. They'll be minute anyways compared to everything else. So basically we want to constrain Vx between max Sx and negative max Sx is what we're doing. Oh, this is bad. This one should be min. We want the smaller of the two. Or do we? Max. This one's negative. What I think what I want to do is just cut. Where's my x? Cut that, paste it here. So we want the smaller of these two and the larger of these two. And that should constrain Vx to be between plus and minus max Sx, which is what we want. Alright, so if it's moving, then accelerate it in the direction of motion, and then constrain the velocity to the maximum. Else, if it's not moving, I kind of fucked it up. Fucked it up a little bit. Where's my shit? Where's my shizzle? Player jumping. Here we go. Alright, so the decay coefficient here. This is going to be a value that we multiply. We multiply the x motion by if we're not pressing any buttons, and it'll slowly or quickly decay. So I'm going to do this by 0.8 to start off with. That's the decay coefficient. And so if we're decaying, we just go Vx times and equals SDX. Was it? Yeah, speed decay of x. And this one doesn't have to be constrained because it's always going to get smaller and smaller. Multiplying by a number less than 1 will do that. So that's what we have. If we're moving, we do one thing. If we're not, we do the other thing. And yeah, that's fine. Okay. On collision shouldn't change. That should be the same difference. And what else we got? On direction release. Okay, we're going to have to change this bullshit up a little bit. Or maybe not. Is moving equals false. That's fine. That's fine. And this one, I want to be able to change my direction in midair because that's one of the things you can generally do. So we're going to revert this back to where it was before, which is core.dir is equal to D. If any direction button is pressed, regardless, change it to that direction. Okay, let's see what kind of bullshit behavior we get out of this. Probably going to be a clusterfuck. Bam! 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 So here we can start slowing our jump if we go this way. If we jump and then press the direction, we can start accelerating. Like bam! Well, wait. Jump and then press, we can sort of accelerate like that. Jump, press. Now, depending on the game, you might want more or less acceleration. Bam! 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 Mario would probably give you quite a bit more acceleration, I believe. Let's go back to player jumping here. What is the deceleration if we're pressing a direction key and we let go? Bam! Basically, we just stop in midair. That's weird. Bam! Bam! I think where our decay value is a little high or low, depending on your perspective. Let's change it to 97. So in this case, it's only decaying by like 3% every frame, which is still quite a bit because you get 60 frames a second, right? So let's try that. Jump and let go. Jump and let go. So yeah, if we let go now, we can change our... here's jumping without letting go. Here's jumping and letting go almost immediately. Bam! So the distance traveled is a lot different. However, you notice that no matter what we're doing here, I think I want to change my acceleration. I want to up it a little bit here. We're going to change our acceleration up to 4.4. We're going to double it. But yeah, no matter what I do, if I jump and then accelerate, whee! Whee! So there we go. We got some mechanics here. We got some systems. Bam! 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 Okay. Enough of me yelling bam into the microphone. What we notice is we can control now our horizontal placement in our jumps to a fair degree. It's not too bad. It could be better, but it's not the worst. We can do some more tweaking and stuff, and that's fine. But one thing we can't control is we can't control our airtime and our height, which are basically dependent on each other. Because basically when we hit that jump button, that's it. You're flying. You're out. You're going. Just like physics has commanded for thousands and billions of years. But if you look at Mario, if you just tap the jump button, he's a little hop. And if you hold the jump button, he just flies up there. So obviously something is happening there. Okay, so here's our standard parabola, our ballistic arc, if you will. Trajectory. That's the word I'm looking for, trajectory. And that's how things would happen under normal physics. Under Mario physics, right? You wouldn't go through your normal ballistic trajectory. If you release the jump button early, you're going to be able to drop off earlier. So if you release it here, you might have a trajectory like this. And of course, it's also possible to like, I don't know. Let's see here. Get some red. Like you could get a trajectory like this, and then you press the left button, and you would end up going like this, right? I don't know. You can get all sorts of crazy shit happening. But the thing we want to implement is we want to be able to cut our trajectory short if we want to. And we'll be controlling that by handling the release of the jump button, early release. So let's go to, what should we check out here? Keyboard. I guess we'll start with sprite state. And we're going to add, we'll copy this. Figure out where my C is. That wasn't the right button. That was a B. There we go. Add another jump here, and here we'll put on control jump press. And here we'll have release. And that's good. Now we need to rename this one in player running and player standing. So we'll go to player standing. We'll go on control jump press. We'll go here, on control jump press. We'll go player running, on control jump to jump press, and on control jump press. Alright, so that handles that. Now, sprite controller, where are you? There you are. I'm going to hit the polling function. And we're going to go down here, control press, and copy this, paste that, change press to release. And we've got the basics lined up there. We've got the framework set out. Let's build it to make sure we didn't forget anything. And we're getting lots of warnings, but so far no errors. So we should be gold. Now, we've got to handle the release of the jump button in the jumping state. So we're going to tell the compiler that we want to override this function, this virtual function, on ctrl jump release. Booyah. Do that. We'll go down here, player jumping. Add a new definition. Player jumping on control jump release. No parameters. Okay, here we go. So here's where this isn't where the magic will happen, but this is where we will handle the release of the jump button. Now, here's how we're going to solve the problem. We're going to create a new Boolean variable. What should we put? Is boosting is kind of what I want to call it, because that's what I have called it before in my prototype. It's not really true, but it's good enough, I guess. Yeah, we'll leave it on is boosting. So basically the concept is as long as we have the jump button pressed, it's going to stay on its ballistic trajectory. So that is what we're going to call being boosted. And if we release jump, it's going to start decaying unnaturally fast. It's going to lose its being boosted status, and it's going to enter into a falling trajectory. So we've got our variable here. Now, whenever we enter the jump state, we're assuming that the jump button has been pressed, right? Because obviously, if you're jumping, you probably pressed the jump button. So in such a case, we're going to go is boosting should default to true. And go to player jumping on jump release is boosting equal to false. So if we release the jump button, we stop boosting. We start our decay of our upward trajectory. Now, here's where the magic happens. I'm going to say here if we're not is boosting and we're moving upwards, which means Vy less than 0.0f. So if we're moving upwards and we're not boosting, we want to decay our velocity. So we're going to multiply it by some value. What value should I put? I'm just debating whether I should make another constant for it. Yeah, why not? Constants never hurt anyone. Constant float. Man, I can't wait until I upgrade to the new version of Visual Studio, because I can initialize all my constants in here just by putting like an equal sign in here. Like, let's see here. I can say equals, 1.0f, and that's fine. I don't have to type it into my constructor and stuff. That's what I want to do. But the old version, the old school C++ won't let us. It's being kind of a dick about it. So, float. What should I put? Speed decay coefficient x. What should we do here? I guess I'll just put speed decay y. It's close enough. Upwards velocity decay coefficient. Okay, now we want to go back. What is your problem? Oh, okay. You want this SDY 0.4. So every frame it's going to decay to 40% of its previous value. So that's a pretty fast decay. Let's put it up to 6 for now. We'll see what 6 does for us. Because, I mean, even like 0.8 is a pretty fast decay. Alright, I gotta go back now. Back to the future. No, more back. Here we go. SDY. So we multiply our velocity by SDY if we're moving upwards and we're not boosting. Stop boosting if we release the jump button. Now this should solve our jump controllability problems. Let's see here. Running, jumping. I'm pressing it right now. Now I'm just going to tap it. Look at that. A little tap. A little tappy tap. Bah, bah, bah. Bam, bam. So yeah, we got a little bit more stuff. Controllability. It's about the lowest we can jump. That's the highest. So it's a little bit. I mean, you can obviously you can fool around with the numbers. Let's say you wanted the decay to happen a lot quicker. You could what do we do? You go back here. You could set your decay to like 0.3. This will cause you to basically immediately start falling as soon as you let go of the jump button. I mean, you could set it to 0, which would make it, automatically start falling. So here, if I just tap it, I can get pretty, it looks lower than my last one. So yeah, a little more immediate falling. Almost immediate, but not, you don't want like it to just automatically start falling as soon as you release the jump button, because that looks unnatural. It looks like kind of janky. You want to give it a little bit of a decay. It'll make it look better, at least in my opinion. But anyways, that's one way to solve that problem. What else? What else can we do here? One thing we could do is we can add a little bit of what's the word I'm looking for? Inertia to the character. Right now, when the character runs, they just start. They just go. They're bam. It's 0 to 6 in a single frame. So there's no acceleration here. It's just you're stopping and then bam, you're going. But if you play like Mario and shit, you'll notice Mario, he kind of he takes a little bit of time to build up some speed. So he has a lot of inertia. It takes a while to build up his momentum. And he takes a little while to stop too. He slides around a little bit. And yeah, you can adjust that stuff too if you want. I'm just wondering whether I should do it in this video or whether I should do it later on. Yeah, I think I'll do it right now. I can split. I'll edit all this shit together, and then I'll see if I want to split it up again or whether I want to keep it all in one video. So, how are we gonna give ourselves some momentum? Well, first of all, we're going to need to add a velocity to our running our running class here. We're gonna need velocity, and we're gonna need maximum speed. That's another thing we're gonna need. And if we also want the character to have to kind of maybe a little bit glide to a stop, not just instantaneously stop on a dime, we're going to want to have velocity for the standing too. So, what we find here is we're going to need a velocity for standing, running, and jumping. And if we need velocity for all those things, why don't we just quit the pussyfooting around, snap the velocity into the core, and then that gives us less shit to worry about passing around and managing in the different states. So what we're going to do is we're going to make velocity part of the core of the sprite. We're going to sprite core here. We're going to go float vx vy. So velocity has been upgraded from just a variable which is specific to a single state to a variable which is, part of the core of the sprite that is maintained between states. So now that we did that, we've got to first of all, we're going to have to revamp our player jumping because we no longer need the VX and VY here. So we got to lose that bullshit. And yeah, get rid of that. Get rid of that. Now here, we're going to make it so that it sets core.vy equal to, I think I had -12 there, right? So here we set the Vy in the body of the constructor. Now we don't have to set the Vx because it should be carried over from the previous state. So we don't set it or anything, we just leave it as it is. And now we go to, what do we go to here? On update. And we go core dot and there and there, there and there and there and there. There we go. Oh, I did the bad thing. There we go. And let's see if I can copy this, paste that there, paste that there. And we're all done. Copy and pasting. Well, looks good to me. Alright, what else? That's it. Okay. So that's this one fixed up. Now, what do we have? Player running. Player running indeed. Okay, so SX is speed. We're going to need acceleration, how fast we get up to speed, and constant float max SX, the maximum speed. So AX, how much acceleration do we need here? We'll give them a pretty big acceleration to start off with, 1. That's quite a bit. I'll put 0.5 so that we can see the effect a little more markedly. Now the max SX is gonna be, I think we had 6 last time, so we'll stick with that. And now we go to on update. That's fine. Core.x is equal to core.transform. Okay, now we don't want this. Core.x is equal to core plus and equal vx. That doesn't change. But here, after we've updated the speed of it, we want to do we want to update acceleration first, and then I guess we'll make it consistent with the jumping. We'll update position, and then we'll update velocity by doing our acceleration. In such a case, we do what? Core.vx is equal to now I'm forgetting what I did back here. Let's take a look at our on update here. It's moving, so we add the transformed acceleration, and then we do this. Let's just copy this bullshit and make sure we don't fuck it up, because copy and pasting, that can fuck you over all the time. Pretends like it's your friend, gonna help you out, and it just fucks you over. So core vx plus core acceleration x. I guess I should have called it SAX to be consistent. Damn my eyes. Okay. Sax and sax. There we go. Now we want to transform this one, add it to the velocity, and then make sure that the velocity is within the maximum speed limit. And finally, advance the frame. We don't touch the Y because we're running, we're only moving horizontally in this engine anyways. So that is running, all fixed up. Now, standing. We want our player to be able to do what? To kind of do a little bit of a glide to a stop here. It's not just an instantaneous stop. It's a little bit of a glide, a little bit of a deceleration. So what we'll do is we'll add protected. What have we got here? Maybe a kind of a decay coefficient again. That's always a good thing. I'm gonna go with constant float speed decay coefficient. Now, what else? I think that's all we really need, isn't it? So we'll just put SDX here, and we'll say that that is, we'll give her a 0.5 6. For starters. Seems like a good deal. And we'll go player standing here. Now, since we're going to be decaying every frame, we're going to have to do virtual void on update. We're going to have to handle the update event. So we'll add that handler here. We'll go over here. I'll put it up here like the rest of them. Void players standing on update. And we'll do Vx times and equals speed decay. Oh yeah, core.vx. Don't forget that. And that should be it. Let's see what I forgot. I forgot something. Something about an SX there. I saw that. What do we got here? Okay, so when we're transitioning from... Okay, first of all, we don't need to pass this anymore because it's part of the core. So we'll get rid of that altogether. We'll go to the declaration of player jumping. We'll get rid of this. We'll go to the definition, because I changed it. I don't have it. Oh, it's right here. Never mind. Definition is here. So, that's fine. What is your problem now? Okay. And if we're going into the jump from standing state, we don't need that. So let's see how slip sliding we are here. Slip sliding away. Okay, so you get a little bit of a delayed start here. I don't know if... Whoa, it gets a little slidey over here, man. Yeah, because you gotta like... The stop is almost instantaneous though. I don't know if you'd want it like that. I kind of like the slidey part here though. Like when you're changing directions, but the stop is just way too fast. So let's fine-tune this a little bit. So the decay of the player standing, we're gonna put this up to 0.85. Let's see how that looks. Okay, that broke something. Okay, I know what the problem is. First of all, I missed some shit here. Obviously, there's no point of having a VX if you're not going to go like this, right? Core.vx, no wait, core.x. Aw, eat a dick. Eat a dick in hell. Where's my plus sign? There we go. There we go. Okay. So first of all, useless to do this unless you're going to actually update your position. Second of all, probably should initialize the velocity value before you use it. Probably a good idea. I mean, just, you know, just a suggestion, really. So let's go to sprite. Let's go to player sprite. Core.vx equals 0.0f. That is not core. That is vor. Vy equal to 0.0f. So we'll initialize those to 0. We will make f's here. Gives it less error, less warnings in the doohickey. Probably. Okay, so that should solve basically all of our problems forever. Yeah, see, look, we got the slide going now. Look at that slide. Oh, yeah. That's so good. Look at that. Yeah. Look at him slide. And you could, like, do other stuff. Like, there's a bunch of different ways you could handle the sliding. The one I did was multiply it by some decay coefficient. Other ones you could do is you could just add to it a certain acceleration value in the direction that's opposite to the direction you're moving. So that will give you acceleration kind of like the acceleration that we have when the player is running, entering a running start. Now, I'm going to change their running acceleration a little bit. I'm going to put it down to 0.4. And the player standing, I'm going to take this to 0.92. Yeah. It's a little different. And there's like I'm saying, there's tons of different ways you could handle that kind of acceleration, deceleration thing. You can have it go in stages where he starts up and then he runs at a certain speed for a while, and then he, after a while of running at that speed, starts picking up to faster speed. Like that's how it works in, I think, Super Mario World. There's all sorts of bullshit you can pull, just based on how much you want to program into your states. But it all fits within the framework of these control messages. So yeah, there was a little bit of derpery by myself there, forgetting to initialize variables and such. But all in all, I think we got a nice little start here on our running, jumping dude guy here. Whoa, whoa, whoa. Alright, so I just wrapped up video and I realized that I'm not done yet. I forgot about a little detail here. This jumping animation, I'd actually prepared two different animations for jumping. One for the rising leg and one for the falling portion, the falling trajectory. I'm having trouble with that word today. But I'm not using the other animation, which is kind of, well, it's not really an animation, it's just a single frame, but you know what I'm saying. So let's do that shit. Okay. So we want to add a new core.seeks. Suck my nuts, man. Just give me the bracket. New by surface, not a by surface, it's a by surface sequence. Just copy and paste this bullshit. I ain't got no time for this. Ain't nobody got time for that. Here we go. Stick, I think it was fall, but I can't really remember. What I should do is I should just pull up my my prototype here. Where is it? I believe this is what it is, but yeah, this is the one. And go down to player falling or player factory. Let's try player factory. And that was the one. Hot dog, we have a wiener. Now we're gonna go here and no, I'm going to change something here. Copy from a different spot. I'm going to copy from here. And then I'm going to go here, paste that. Oh, my capitalization is not standardized there. That's fine. I'm going to need 4 instead of 3 here. And we're going to need to do... Oh, suck it! We need to delete this last one. So that will initialize and free up our new sequence for the falling animation. Now, there are two ways you can go about this bullshit. One way is you can create two states. One state for the rising trajectory and one state for the falling trajectory. And that's fine. That would work reasonably well. That is what I did in my prototype. But the thing is that for the rising and the falling on the jumping action, they're rather similar. They have a lot in common. And so I feel that it's more productive just to merge them into a single state like we've done here. I feel there's no need for them to be split apart. So if you're going to have a single state but two different animations, you're going to need to be switching your animation halfway through or whatever way through. To do that, we're going to go to update. So we'll go player jumping, update. And what shall we do here? We'll say if core.vy is greater than or equal to 0, meaning that we are moving in the downward direction, because positive numbers mean down, then what should we do? We should go core dot current sequence is equal to core dot seek4. All right. So this will transition us into the downward motion. Is it 4 or was it 3 now? I can't remember. Let's go back. We ought to make sure that this is the correct way. Player sprite. It is indeed 3. So we just saved ourselves a little bit of debugging there by not derping it up. Not herping the derp today. At least not in this recording. As for the other recordings, well, that's a different story. So now we got the rising and the falling. Just rise and fall. Boing, 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 boing. Wow, that's annoying. I should really find a way. The reason why he's jumping like this is I'm just holding the button down, by the way. It's because of auto repeat. I should really figure out a way of a nice way of disabling the auto repeat. I know of a couple ways, but it's not a real big issue right now. But it's something you might want to think about in your own games, whether you want auto repeat to be a thing or not. So yeah. So now we've got different animations for rising and falling. And like I said, you could handle that by having separate states if you liked, but meh, this solution is fine. We're setting it every single frame when we're falling, but that doesn't matter. It's a very small little operation. It's not going to cause us a huge amount of overhead. So yeah, that is it now. For sure, for realsies, I am super done now. Super done.